In this video, you're going to learn how to find an inverse function algebraically. We're given a function f of x equals 5 minus x divided by 3x plus 2. The first thing you want to do is to graph the function and see if it passes the horizontal line test. And you do this to determine whether or not it's worth the time trying to find the inverse function. If it passes the horizontal line test, then you can proceed. So I decided to graph this in Desmos. Here you can see we have a rational function, and it does indeed pass the horizontal line test. Okay, it gets a little interesting along or just below the x-axis, but it's pretty clear now that we're familiar with rational functions that there's a horizontal asymptote. So it passes the horizontal line test, and now we can proceed to the next step. We're going to replace f of x with y. And really, that's just for simplicity's sake. Next, we're going to swap x and y. So everywhere you see a y, you write an x, and everywhere you see an x, you write a y. And the reason you do that, excuse me, I almost did not follow my own directions. The reason you do that is because the inverse function interchanges x and y's with the original function. What was an x and y on the original function is now a y comma x on the inverse function. Now we're going to solve this function for y. So in order to do that, I'm going to multiply both sides by 3y plus 2. So we have x times 3y plus 2 equals 5 minus y. Now it looks like the best route I could take is to distribute this x. Now remember, we're trying to solve this for y. I have y in two places. What I'm going to do is to get all my y's on one side of the equation, and then I'm going to factor out the y. So I'm going to subtract 2x on both sides. Now I'm going to add y on both sides. So we have 3xy plus y on the left, 5 minus 2x on the right. I'm now going to factor y out as a greatest common factor. And now I'm going to divide both sides by 3x plus 1. And I have y equals 5 minus 2x divided by 3x plus 1. So I'm done with step 3, which was swap x and y, and I really should add in here, and solve for y. Now I'm going to replace y with my inverse function notation. So that's my inverse function. My last step is to verify that that is indeed my inverse function. And in order to do that, remember here, to verify means I'm going to take my inverse function and plug it in to my original function, and I should get x in return. And when I do the opposite of that, taking my original function and substituting it in for my inverse function, I should get x in return for that also. So let's go ahead and let's do that. So this may take a little bit of time. excuse me. So we have 5 minus x, which is now 5 minus 2x over 3x plus 1. We have 3 times x, which is now 5 minus 2x over 3x plus 1 plus 2. And now we have quite a bit here to simplify, but let's go ahead and do that. So I'm going to find common denominators in the numerator. So if I multiply this by 3x plus 1 over 3x plus 1, I will get in my numerator 15x plus 5 minus 5 minus 2x all over 3x plus 1. And then in my denominator, I have 15 minus 6x, and I'm going to get common denominators in my denominator also, so I'm going to multiply this by 3x plus 1 over 3x plus 1. This becomes plus 6x plus 2 all over 3x plus 1. Now I'm going to try to clean this up a little bit so I could distribute this negative sign. So this is going to become 5 minus 5, so those 5s are going to cancel out. And it looks like I'm going to be left with 17x over 3x plus 1. And in the denominator, it looks like those x's cancel out. And I'm left with 17 over 3x plus 1. And now if I remember dividing here is the same as multiplying by the reciprocal. We have 17x over 3x plus 1 times the reciprocal, 3x plus 1 over 17. Those cross simplify, 17 simplifies out, and we're left with x, which is exactly what we're looking for. So we should also, we've checked, or we've verified it by inputting the inverse function into f. We should also verify by substituting f into the inverse function. I'm going to leave that for you to do because, as you can see, the algebra takes a little bit of time. And oftentimes the verification is longer than finding the inverse function to begin with. So I'm going to end this video here now that you've learned how to find an inverse function algebraically following these 5 steps.